Good evening. Hope everybody's having a good Tuesday here. This is what it looked like outside the Texas weather studios here, if you want to call it that. There's the moon and Venus down there at the bottom. Very pretty sky here. It's a bit quiet, but we've got a lot to cover for today. We've got storms in the Great Plains and, of course, Hurricane Matthew starting across Cuba. This is what the current radar picture looks like across Kansas and Oklahoma. You can see a pretty large broken area of thunderstorms all the way from north of Omaha down to the Oklahoma City area. Some of these have had, we actually have tornado watches on these cells. There's the tornado watches we have in effect, two of them, one for central Kansas around Wichita and the other around Oklahoma City. We can take a look at one of these storms. Looks like the heaviest activity is around Wichita. So we'll zoom in on that real quick. These storms have just passed through the Wichita area in the past hour. Now, one thing you can look at to really get a handle on these cells is the outflow boundaries. See, we have one outflow boundary just out ahead of these storms. And when we're talking about a strong tornadic storm, we really like to see that outflow boundary pulled into the inflow region, kind of like that. When you have the outflow boundary pushed out ahead of it, that's a good sign that your cell is becoming outflow dominant. So this cell actually looks pretty decent, probably going to stay severe for a little while. Of course, the other clue is up in the velocity imagery. Now, I haven't set this up just yet for storm relative velocity, but what we're looking at is a lot of red here. This indicates a lot of velocities away from the radar. And that also includes the element of rotation heading back towards the radar. But we have to cancel that out by subtracting the storm motion vector. Now, the way we do that, we click on, there's a setting at the very top where you can do that. You can set the storm motion vector. I'm going to put in 240 at 25 and try to subtract out some of that motion. And now you can really see the details. So we have a strong inbound couplet right there. Strong inbound velocity right there. Both of these are actually the couplet, and this is the outbound segment right here too. So we're looking at a diameter on this particular cell near El Dorado, Kansas, about 5 miles. So that's going to be definitely in the mesocyclone range. So this does not look tornadic at this time. But we have 26, 30 knots outbound, about 40 inbound, so that's about 70 knots of shear. So that's a pretty good rotating storm right there. What's going on elsewhere across Kansas? Really not a whole lot. These cells look to be a little bit on the weak side. And, of course, we've also got some stuff going on down in Oklahoma. This is what the visible imagery looked like about an hour ago. And you can see these towers growing and casting these very long shadows about 100 miles to the east. Right now, this is the radar imagery. We've got one lone cell here north of Chickasha, Oklahoma, moving into the Norman Moore area. And it has the appearance of being, I would say, probably somewhat inflow dominant. So this is probably a slightly high-based cell. Oklahoma City, of course, is not out of the woods. You know, of course, we'll have to keep tabs on that, and I'm sure there's spotters out there, you know, watching this, but that's going to track in an Oklahoma City area in the next 15 to 20 minutes. Right now, doesn't look like any really strong, severe signature. So that brings us out to the Caribbean. And we've got Matthew here coming on shore onto Cuba. And we've got a Category 4 here. You can see sustained winds 120 knots, which is 140 miles an hour. The pressures have come up to 949. They were in the 930s yesterday. Now I'm going to throw in a little segment here real quick. Let me click on my little buttons here. Yes, it's the geography segment. I've got something interesting here. So what does this look like? Better turn the sound down here. So, see if you can guess where this is. This is relevant to our forecast today. So you see some pine trees there. Looks very, very wet, doesn't it? Some flatlands there. Yeah, that might give you a hint right there. Okay. All right, so we're definitely close to the coast here. Any ideas what this is? Okay, this is just a few miles away. Okay, so now you can probably figure out we're looking in the Caribbean here. What you have just seen is a little tour of Andros Island in the Bahamas. This is about 150 miles east-southeast of Miami. And look at that. We've got forecast tracks going right over that island. So those guys are going to be in the path here. And this is a quick look at what the map looks like on Andros Island. You can see to the west of the island a lot of marshy, flat, saltwater marsh type stuff. And most of the settlements are on the west side. And the high point on this island is right around here, 62 feet above sea level. And when I was researching that earlier, they've got that listed on a mountain climbing site, and nobody has apparently visited it. So if you want to fly out there and get your name on the record books, you can definitely do that. Forecast tracks, you can see they've started bending to the west here. So now we're looking at Florida being possibly in the path of this thing. And the real outlier, let's see, the HWRF and one of the Navy models is going for landfall there actually. But looking at the history of these storms, the history of the models, the large international models, the European ECMWF and the NOAA GFS models, those have been by far the most accurate. And what do we have for those? Where's the GFS? Let me see if I can find that in this spaghetti tangle here. Let's see. Avno, there we go. Got to click on this to figure out exactly. It's one of the purple ones, I think. Or is it the blue one? Okay, come on. I'm getting off track here just a little bit. Let me get up here. Let's see. Avno is going to be purple. It's going to be one of the purple ones. So, yeah, there we go. It's going to be this track right here. So that's going to be the GFS track, taking it almost all the way to the South Carolina coast. The European models are going further westward. And the ECMWF has actually had the best 5-day track history for the current position. So we do have to kind of, we probably have to watch for that possibly actually panning out here. So Florida is possibly under the gun here. This is the, let's see, I had the model performance up earlier. Let's see, where'd that go? Yeah, there we go. There's the average position error for the current location. And you can see down here the ECMWF had pretty much almost had this nailed. The UK Met, same story. And as we go up, we get into higher factors of error. There's the GFS right there. Then as we go higher, we get up into the Navy models and the GFDL. The GFDL is actually one of the better models, but it didn't do so well this time. And as you go higher up, you start getting to the statistical models. So what do we got down there? This is the polar orbiter imagery for Matthew. You can see a lot of white here. This looks like white cloud material. Well, I took this into PaintShop Pro and ran some filter enhancements, and there you go. You can really see the eye there. So definitely a lot of cirrus covering that eye, but if you mess around with a palette, you can really bring out some good detail there. So this is the current satellite imagery, and it's continuing to shift north, but one thing you can see, we're starting to bring a little bit of drier air from the Cuban region that's entraining it southward into the circulation, and so we're getting a little bit more of a symmetric appearance to the eye right here. However, it's going to continue moving north, probably weaken a little bit, then start to strengthen a little bit as it gets out into the Bahamas. And this is the Guantanamo ARSR-4 radar. This is an air traffic control radar. They use that for also weather detection there in Cuba. And there you can definitely see the eye about maybe 40, 50 miles west of Guantanamo, which is right here. So what kind of weather are they getting right there in Guantanamo? We can check that out. This is the METAR listing from the Aviation Weather Center. And let's see here, 0056, is that current? Yeah. Wow, this automatically updates. That's pretty cool. So reading these plots here, going from the bottom to the top, we go from oldest to newest. So we're getting some gusts up to 36 knots, which is about, it's going to be about 42 to 43 miles per hour. Getting some light rain. You can see visibility is about 6 miles, so that's not too bad. And the cloud bases, the ceilings are about 7,000 right there, so that kind of shows you some of the dry air that's being pulled southeastward from the inland areas. So yeah, it is a little bit stormy there, but could be a whole lot worse for sure. We could have ceilings down to 3,000 feet and winds a lot higher if we were more towards the center. Okay, so what are we looking at for the forecast? Man, that was a mouthful. Let me check and make sure I didn't miss anything here to show you. Let's see, we did GR level X, we did the geography. Yeah, I think we're set here. So let's look at the 2-week forecast. Now we're looking at the model depiction here. This is the GFS showing thickness, and you can see the thickness in red right there, the red dashed lines, and the pressure, which is the black isobars. And you probably remember from watching this webcast that we like looking for the thickness gradients. That's where the thickness lines, these red lines, are packed very close together. And here we have another gradient, lines packed very close together. These are frontal zones here. And we always find the actual surface fronts on the south side of those frontal zones, so kind of like that. So if we take that rule of thumb and just kind of draw these in, we can get the position of the surface front pretty easily. So if I want to use proper colors here, I'll just use red for the warm front. There you go. So you see that's actually, the concept there is pretty simple. So this is showing a cold front from around there in Wichita, where those storms are, all the way down to Lubbock and down to the Tucson and Yuma area. Now, do we see that on the actual observed surface data? Let's take a look. Yeah, we kind of do here. See that arcs backwards, and then we pick up this convergent zone. And the convergence that we see here, that's probably going to be associated with the front. So that's another thing you can use to kind of pin it down. Another tool you can use is potential temperature. A lot of websites don't have this. Digital Atmosphere actually does. And the way you get to that, you go to data, or you go to analysis, then temperature, and then potential temperature. I don't know if it's showing this. But anyway, you plot that there. That can kind of help you pin down a little bit some of those zones. The problem is when you get out towards the oceanic areas, you start getting some of the cooler marine air getting close to the warm inland air, and you start getting these weird gradients here. So that can kind of mess up your analysis a little bit. But if you use this very wisely, you can find some important zones. Like right here, this looks like a possible frontal zone right there. So something like this is probably where I would end up placing the surface front. So we saw from the thickness chart to start looking in this area, and I decided to draw that a little bit further north. Now I could probably make another case for it being here, because we have west winds there at Albuquerque and north winds here. So this is kind of what you go through when you do analysis. You look at all your tools, you look at trends, and you look at soundings to get kind of a 3D picture of what's going on, and even a 4D picture using time. And further out west, let me replot this. Further out west, you can definitely see the fronts in Kansas. When these fronts get out into the plains, they become a lot more easy to pick out on the surface charts. So there's our cold front moving into the Wichita area, and then we start picking up actually a dry line through Oklahoma. So that's a dry line right there. See the difference in values? We have 43 there at Clinton and 66 in Oklahoma City. And we've got that one storm there near Oklahoma City. We can take one last look at that. There it is. We're starting to get a little bit of a hook echo there. So since we're not locked into a format where we have to move along and close up, we can go ahead and pull that up real quickly. So let's do that. Before I load it up, you can see from the Wichita radar, we're scanning this storm here at about 18,000 feet up, so this is pretty far out. And one little interesting artifact, you see these lines shooting like this? This is very indicative of electrical activity in this storm. It's sending out RF energy back to the radome at intervals that don't correspond to the radar pulse. So the radar just plots it wherever along that radial. So this is probably a very active storm electrically. Excuse me. Voice is starting to wear out here. So let's click on the Twin Lakes radar and get a closer look down lower at that storm. So we've got a severe weather warning on that, 8:16 p.m. there. They're showing radar indicated hazard there for severe storms, ping pong ball sized hail, 60 mile an hour gusts. So we are developing a little bit of a hook there, but this flat appearance here, that kind of tells me that it's still a little bit high based. So we may just be seeing some of the wraparound into the meso. So let's check that out. Let's plot the storm relative velocity. And there we can see a little bit of a couplet, a little bit tighter, but the intensities are not really that bad. See right here in the zone here, I'm reading off the bottom. Let me pull that up so you can see that. I set the cursor right here. We're seeing 4 knots inbound right there. See that 4 knot right there? And on the north side, we're seeing 43 knots outbound. So just for the heck of it, I can fix the motion vector just a little bit. Let's see, there's 6 inbound, 46 outbound. Well, that didn't help a whole lot there, but in any case, you can see that the circulation is kind of on the weak side. If we use standard base, let's see here, we've got 24 in and 10 out, so only about 30 knots of rotation there. And that's across a diameter of about 1.5 miles, so that's kind of a tight mesocyclone. Probably got a good wall cloud spinning there, and I would definitely keep an eye out for, have spotters on there, just in case one little tornado squeaks out of there. That's, that could always happen. Let's check out the storm spectrum width, not really showing anything there. So I don't really have a good handle on where the outflow boundary is. Can't really pick that out too well. I see something here, that might be it. And what else can we look at? Let's see here. We can go up to the mid-levels real quick. I'm not going to keep you all too long, but we'll just check this out really quickly. Go up to the higher levels. Let me fix the motion that I put in here. So there you go, up in the mid-levels, this is going to be the 5.1 degree scan, up at 11,000 feet, and we can see right here, this is inbound velocities toward the radar of about 62 knots. And then right here we have outbound velocities of 10 knots, so that's about 70 knots of shear. So that's going to be a pretty good mesocyclone spinning right here. So that's going to be the center right there. So it's sitting right above this vault area you see here in the low levels. Yeah, right there. There we go. So that's the low levels. So this storm does have overhang. And I'll show you a very quick look at that using 3-dimensional a three-dimensional scan. This is looking eastward, and there you can kind of see the updraft. Sort of. Can't really pin down exactly where it is, but it's probably doing something like this here. Okay, so that's your Oklahoma storm. Let's see here. If we had a tornado on the ground or something like that, I would probably stick around for that, but I think we'll probably be done for now. Let me check the chat here and say hello to the usual people out there. Mark, Mike, Ron, Mike Bexley. I see you guys on here pretty regularly. And let's see here. Yeah, somebody said sirens are going off. I'm not sure whether that refers to Wichita or Oklahoma City. But in any case, you can continue to look at these products yourself. A good place to go after the webcast if you want to check this out. Go to weather.cod.edu. And they've got this weather analysis tools. You go to satellite and radar. And you go down to the NextRad sites right here. And they've got some pretty decent tools here you can use. They've got some mesoanalysis products, like if you want to mix surface plots and stuff like that, you can definitely do that. You can, let's see, I think you have to do that actually with the larger scale, like the 1 and 2 kilometer sectors. But you can see right here, there's a lot of products you can look at, and they've got the whole range there of dual pole products, and we'll probably go over that on one of these other webcasts when we don't have so much going on. Dual pole, that's kind of a new thing that came out about 4 years ago, so we can definitely learn a lot about that, especially as we get into winter weather season. And let's see here, 8:23. I think I'm probably about done here, and I appreciate you guys watching. We're going to cover Matthew again tomorrow at the same time, 8 o'clock. Thanks for checking in, and we'll see you tomorrow.